In this video, we are going to solve the traveling salesperson problem in the simplest way. Here, the question given is that suppose a salesman has to reach city number 10 starting from the number 1 by his car. Though his starting and destination cities are fixed, he has option of traveling through routes. Cost Cij for as a standard policy for car driving running from city I to J is given below. Find the safest route of traveling so that the total traveling cost is minimum. So this is the minimum. This is the traveling salesman problem, and we have to find the minimum cost for his route. The salesperson is traveling from Salesman is traveling from city 1 to city 10. In between all the city, we have to make a path selection such that his total cost for the route will be minimum. So we solve this in the step-by-step way. So first step, here also the cost for traveling from one city to other city is also given. So these are the 4 tables for the cost matrix is given. So we will consider the step 1. We will consider the first matrix, that is that is given, that is 2, 4, 3. From city 1 we have option to go to the city. From city 1 we have option to go till the city 2. From 1 we can go to city 3. From 1 to 4, and the value from 1 to 2 is 2. From 1 to 3 is 4. From 1 to 4 is 3. There are no competitors for this route, so this will be the minimum cost for 1 to 2 route, 1 to 3 and 1 to 4 route. Now we will go for the next step. We will consider the next table, the given here, that is step 2. We will go for considering the next table. That the table is given, that is for 2, 3, 4, city 2, 3, 4 with 5, 6, 7, 4, 6. For going from city 2, we have option. From city 2 we can go till 5, 6, 7. From city 3 we can go till 5, 6, 7 cities. From city 4 we can go to 5, 6, 7 cities. Now we will solve this and we will see what we are getting. For this particular thing, we will find the solutions. For city 2, as we have started with 1, for city 2 we are having 3 options, so we will write that is for 1 to 2 and 2 to 5 we will go. From city 2 we can go, this is option for the city 2. From city 2 we can go till 5, 6 and 7. This is first choice. Now we have to go from 3, but we have started from 1. So from 3 we can go till 5, 6 and 7. From city 4 we have started from 1. We can go till 5, 6 and 7 city. Now we will complete this path route, that is 1 to 2, 1 to 2 to 7, 1 to 3 and 3 to 6, 1 to 3 and 3 to 7. Now 1 to 4, 4 to 6, 1 to 4 and 4 to 6. Now here what we have to do, we have to find the cost value of each this route. The cost value for 1 to 2 is already given in the previous iteration. This was the result for the previous iteration, 2, 4, 3. So that is 2, 2 plus the cost value for going from 2 to 5 is 7. For 2 to 6 is 4. For 2 to 7 is 6. In the same way, cost value for 1 to 3 was already given, it was 4. So we will just write 4, 4, 4 common. And for going from 3 to 5, we have cost as 3. 3 to 6 cost is 2. Or 3 to 7 cost is 4. Now going from city 1 to 4, we are having constant value of 3. This will be common for different parts. And for going from 4 to 5 we have cost of 4. For 4 to 6 we have cost of 1. For 4 to 7 we have cost of 5. So we will calculate this and what we will get. So this is coming out to be 9. 4 plus 2 6. 6 plus 2 8. 4 plus 3 is 7, 4 plus 6, 4 plus 4 is 8, 4 plus 3 is 7, 3 plus 1 is 4, and 3 plus 5 is 8. Now what we have to do, we don't have to calculate this and we will have continue for the next. What we have to do exactly in this, here the destination cities till this half path was 5, 6, 7. So we have to find a minimum path for 5 city 6 and city 7. So what we will do, we will write the end city here. These are the cities which are ending with the 5s. So from this, which one is the minimum? This is, so minimum route for going from 1 to 5 is, what is the minimum among all this? From 9, 7 and 7, minimum is the 7. So I am minimum entry is 7, and so we can pick any path. So I am choosing this. So this is the 7, and we have choose this path via 1 to 4 to 5. So going from city, from going till city 6, we have which is the minimum path. So for going till city 6, these are the options available we have, and among all these values 6, 6, 4, 4 is the minimum value. So minimum path for going from city, minimum path for going from city 1 to 6 is of 4, and which is coming from the city 1 to 4 to 6. And the last is for going till the city 7, what is the path we have from all of these options, which is the minimum value. So these are the options available. From all of this, all entries are having value of 8, so we can pick any one. So I am picking this first entry. So minimum value for going from 1 to 7 is of 8, and that is coming from the route 1 to 2 to 7. So these are the minimum values we have founded in this particular iteration. That is the minimum value for going from 1 to 5, 1 to 6 and 1 to 7 is of 1 to 5 is 7, 1 to 6 is 4, and 1 to 7 is 8. And this is coming from the route 1 to 4 to 5. This is coming from the route 1 to 4 to 6, and this is coming for the route 1 to 2 to 7. Now we will move for the next iteration, that is step 3. Now in this we will go for looking the next column we have given with. So this was the column we have given with. Now from city 5 we have option to go till the city 8 and 9. So in the same way what we will do, we will write the path from 1 to 5. We have option to go till 8 and 9. In the same way from city 6 we have option to go till 8 and 9. From 7 we can go till city 8 and 9. What we will do, we will complete this path. So 1 to 6, 1 to 7. Okay. Now from city 1 to 5 the minimum value was 7 in the previous iteration. So we will just pick that value as it is, 1 to 7. From 1 to 6 the value was 4. So we will just write that as it is. 1 to 7 value was 8. Now from going from 1 to 5 and 5 to 8, 5 to 8 value is 1. 5 to 9 the value is 4, 6 to 8 value is 6, 6 to 9 value is 3, 7 to 8 the value is 3, 7 to 9 the value is 3. So we will calculate this, and this will coming out to be 8, 11, 10, 7, 11 and 11. Now here the destination cities are 8 and 9. So we have to find the minimum value which is coming till the city 8 and 9. So we will consider for the city 8. The minimum value among all these cities for city 8 is, here we will write minimum value which is coming from 1 to 8 is of 8, 10 and 11, that is 8, which is equal to 8, and which is coming from the route 1 to 5 to 8. In the same way, we have to calculate the minimum value for city 9. So which is the values are 11, 7 and 11. So this is the minimum value. So minimum value for coming from 1 to 9 is of 7, and which is coming through the root 1 to 6 to 9. Now till this we have completed. Now we will go for the next step, that is the fourth step. Now we have only one table. So what we are doing, we are going from city 8 and 9 to the city 10. But from these two city, which one will be the best, as the result will be the same, but we have to backtrack for finding the perfect solution. Right now what we will do, we will find from city 8, 1 to 8 to 10, and from 1 to 9 and from 9 to 10 what is the value. 1 to 8 value was 1 to 8 the value was 8, 1 to 9 value was 7, plus from 10 to 8 to 10 the value is 3, plus 9 to 10 the value is 4. To make sure that whatever thing you did or whether your final solution is correct, you can check the final lastmost cities having all the result as same. So 8 plus 3 is 11. The same way 7 plus 4 is 11. From these two, both are equal. So in these two cities, we have to choose which one is the best city. Now in this we can check the city which is having the minimum value in between that. So the city which was having the minimum cost of traveling was this city 9. So for city 9 the cost was 7, and for city 8 the cost was 8. So what we will do for finding the solution, we will consider city 9. So we are going in the backward direction from 10 to 9 until 1, but from 1 to 9 which path we choose. From 1 to 9 we chose this entry, and this was the path of 1 to 6. So we'll just write the path till the 6th. For 1 to 6, which was the minimum path we choose in this iteration, for 1 to 6 we choose this entry, these values, and the path was traveling coming from the 1 to 4. So we will write the final city was 4. Now coming from 1 to 4, which was the path we chose in the previous iteration, only this was the path we were having. So the final solution for this is the cities which are giving the minimal cost traveling cost as these cities, and the path is the minimum path is the minimal cost path is traveling cost path is 1 to 4, 4 to 6 and 6 to 9 and 9 to 10 with cost of value 11. So this is our final solution. Thank you.